Hi, welcome to Topics in Macroeconomics. This topic is the Fisher effect. In the previous video, we defined the expected real interest rate as being equal to the nominal interest rate minus the expected rate of inflation. To obtain the Fisher effect, we can rearrange the above equation to produce a relationship between the nominal interest rate and expected inflation. In writing out the above equation, I have made the simplifying assumption that the real interest rate is constant and known with certainty. The Fisher effect predicts that the nominal interest rate adjusts 1-for-1 with the expected rate of inflation. For example, suppose the real interest rate is 2% and the expected rate of inflation is 3%. Then according to the Fisher effect, the nominal interest rate will be 5%. Now suppose the expected rate of inflation increases to 5%. Then according to the Fisher effect, the nominal interest rate will rise to 7%. We can show the Fisher effect using a simple diagram. On the vertical axis, we measure the nominal interest rate. On the horizontal axis, we'll measure expected inflation, where I denote expected inflation by the symbol pi(e). Notice that expected inflation can be positive or can be negative. In the case of negative expected inflation, we have expected deflation. When expected inflation is equal to 0, we see that the nominal interest rate will be equal to the real interest rate. To show the Fisher effect, we draw a line with a 45-degree slope that cuts the vertical axis at the real interest rate. In our example, I've assumed the real interest rate is equal to 2%. To show the Fisher effect, we choose a value for expected inflation. In this case, I've chosen 3%. And then we simply read from the blue line the value of the nominal interest rate. In this case, it will be 5%. The nominal interest rate is equal to the real interest rate of 2% plus expected inflation of 3%. So far, we have assumed that the real interest rate is constant. However, we can relax that assumption and write the Fisher effect as the following. The nominal interest rate is equal to the expected real rate plus the expected rate of inflation. The Fisher effect holds provided that a change in the expected inflation does not affect the expected real interest rate. In practice, when we observe a change in the real interest rate, it may be difficult to distinguish whether that change is due to a change in the expected real rate or a change in expected inflation. See you next time.